Hello students, so in the previous class we looked into the solution for ordinary differential equation of higher order with variable coefficients. Now we are going to cover the very last topic in this chapter, which is basically variation of parameters, right. So how do we determine the solution for second order ordinary differential equation? Basically we will stick to the second order that we will see in this chapter, right. So I will start with little bit theory, and if time permits, then I will solve one example. I think that will cover this topic, because most of the examples will be analogous to the theory that I am going to explain, and that is basically the conclusion of this particular topic. All right. So suppose, to start with, suppose we are given d square, we are given yes, d square, what is happening, pen, yes, d square y by dx square plus capital P dy dx plus capital Qy is equals to capital X, where I call this as equation 1, where capital P, capital Q and capital X are the functions of x only, right. It may be possible that you have p0 into d square y by dx square plus p1 into dy dx plus p2 into y equals to, let us say, x cap. Then you divide both sides by p0, and then you will have p1 by p0 as capital P, p2 by p0 as capital Q, and x cap by p0 as capital X. So we can always try to put it or put the ordinary differential equation that is given to you into this form. It is possible when you divide it by the first coefficient, provided that whatever p0 we have, it shouldn't become 0 in the domain of definition for this ODE. Right. Now let y is equals to AU plus BV, let us call it equation number 2, be the complementary function, be the complementary function of the equation 1, right, where A and B are constants, where A and B are constants, and u and v are functions of x and are independent solutions, solutions of the corresponding homogeneous equation, that means when capital X is 0, homogeneous equation. Then what will happen? So since u and v, they are both solutions, so we will have d square u by dx square plus p du dx plus capital Q u is equals to 0, and we will have d square v by dx square capital P dv dx plus qv equals to 0. This is equation number 3. Achha. Now let us assume y is equals to phi u plus psi v, not psi, this should not be a bracket, only psi v is the complete primitive. That means let us assume B the complete primitive, be the complete solution or complete primitive or solution, they are same, primitive of the equation 1, where we take phi and psi in place of A and B, in place of A and capital B. right, and they are no longer constants, and they are no longer constants but functions of x, to be chosen so that 4 where is that? So, let us call this as equation number 4. 4 will satisfy 1. So, we have to determine our phi and psi such that phi u plus psi v, this will be a solution or the complete primitive, that means the complete solution of our given equation 1, right. So, we will determine what is our phi and psi. So, let us choose phi and psi such that u into d phi by dx plus v into d psi by dx equals to 0. This is equation number 5. So that when we have dy by dx, then it will be phi du dx plus psi. So, phi du dx plus psi dv dx, because when we are choosing u and phi and psi in such a way such that this is satisfied. So, then in that case, if I differentiate both sides here with respect to x, so we will get u into d phi dx plus phi into du dx plus v into d psi dx plus psi into dv dx, but this is assumed to be 0. So, that other two terms, they have become 0 and only this has survived. Now, if I differentiate this again, let us go to the next page. If I differentiate this again, then it will become d square y by dx square equals to phi d square u by dx square plus psi d square v by dx square plus d phi dx into du dx plus d psi dx into dv dx, right. Now, we will substitute all these values in our original equation number 1. So, if I substitute all these things, then we will have phi into d square u by dx square plus capital P into du dx plus capital Q u plus psi into d square v by dx square plus P into dv dx plus q v plus d phi dx into du dx plus d psi dx into dv dx. This is equals to capital X, but u and v are the solutions. So, this will be equals to 0, this will be equals to 0 because they are the solution of the homogeneous equation. So, they both will equate to 0. So, ultimately we will be left with only this term. So, this is d phi du and then du dx plus d psi dx. So, d phi dx, now it is not u, it is d phi dx du dx d psi dx then dv dx equals to capital X, right. So, this is our equation number 6. So, we have equation number 5 and we have equation number 6. Okay. So, now what will happen is sorry, okay, now it is there. So, now what will happen is this is equation number 6. So basically we have d phi dx, du dx, d psi dx, dv dx equals to capital X, and from that choice of u and v sorry phi and psi in such a way that d phi dx from equation number 5 into u plus d psi dx into v equals to 0. So this is equation number 5 which we have just written, right. So basically you can see this as a system of equation in variable d phi dx and d psi dx. So this is basically our 2 by 2 system with 2 unknowns and 2 equations. So we will end up getting a unique solution, right, and we are basically solving for phi and psi, because u and v we can determine very easily. U and v are the independent solutions of the homogeneous equation. So that can be determined very easily. We are just looking for phi and psi. So phi and psi can be determined from these 2 equations. Now it can be determined like this, that solving for d phi by dx and d psi by dx from equation 5 and 6. So this we get. So this will give, this is very simple to calculate, d phi by dx equals to we'll have v into capital X divided by the determinant, that is v. So we are covering this. So this will be v into capital X, and we'll have v into du dx minus of u into dv dx, and d psi by dx equals to u into capital X with a negative sign, v into du dx minus of u into dv dx. This is coming from directly that solving a 2 by 2 system, either via Cramer's rule or cross multiplication, whatever rule you know. So this can be given directly, right, and this actually gives a unique solution. Now you have basically an ordinary differential equation. On the right hand side we have entirely a function of x, and on the right hand side, on the left hand side we have d phi dx. So this can be further written as, if you integrate, this will become d phi. So this will become phi, which is equals to d phi, which is equals to integral of v capital X v du dx minus u dv dx, right, plus of course some constant of integration c1, and psi can be given by integral of d psi, which is basically integral of minus u x dx, there is a dx here, divided by v du dx minus u dv dx plus some c2, right, where c1 and c2 are arbitrary constant of integration. So here basically why it is called method of variation of parameter, because now we have the solution, right. We can write y is equals to phi u plus psi v. We know our u and v from the homogeneous equation, and we know our phi and psi, their multiplication will give you the required complete primitive or complete solution. So if you know your phi and psi, you can write the solution very easily. The reason why it is called variation of parameter is that initially we are saying that au plus vv is the solution of the, or is the complementary function of the auxiliary equation. Now instead of taking a and b as constant, we are making them basically functions of x. So we are just changing the parameter. So we changed it we changed a and b by the function of x, so phi and psi, and from there we are basically trying to determine our phi and psi such that it will be solution of the original equation, because in original equation this is what we are getting, this is coming from the first equation, and this is due to the choice of phi and psi. Then we will solve, and that will give us the required solution of the original equation, right. So this is what we basically mean by method of variation of parameter, that instead of taking a and b, you choose 2 functions and you are just varying those 2 functions, or playing with the 2 functions in such a way so that you can determine phi and psi with the help of u and v, and of course capital X. Let us solve one example so that things become more clear. and no longer theoretical. So let us move on to one example. Example 1. So solve by method of variation of parameter, by method of variation of parameters. The equation d square y by dx square plus a square y is equals to sec ax. This is equation number 1. Sec is our 1 by cos. So here the complementary function or the auxiliary equation, let us write everything. The auxiliary equation, by the way, this can be solved by using that this DFD operator technique and using this second order equation for constant coefficient. That method will always work. It's just that here we are specifically choosing this variation of parameter technique to solve it, right. Okay, so the auxiliary equation corresponding to 1 is m square plus a square equals to 0. We are assuming a to be positive, so it is better to write a as positive. So here this will give m is equals to plus minus ai, or a can be any real number. We can write a as any real number, does not have to be positive. So a can be any real number. So m is equals to plus minus ai, right. So therefore the complementary function, the complementary function corresponding to 1 is ycx equals to a cos of ax plus b sin of ax. Up to here we can write, where a and b are arbitrary constants. A and b are arbitrary constants. All right. Now let y is equals to phi u plus psi v be the complete primitive, be the complete solution or primitive of the equation 1. Okay, of the equation 1. Then by the way, here we can where u is equals to cos ax and v is equals to sin ax are the independent solution of the homogeneous equation corresponding to 1, corresponding to 1. So that means if instead of sec ax, if we take it as 0, then u and v are the independent solution. Since you can also verify this, we can check the Jacobian. So that is u v and u dash v dash, right. So this is u v dash minus u dash v. So u is cos of ax and v dash is a cos of ax, and minus of u dash is a sin of ax and v is sin of ax. So this will become a cos square ax plus sin square ax, so that is 1. So this is equals to a. So provided a is not equals to 0. So here a is a real number, but it is not equals to 0. That is very vital. Otherwise it will not be an independent solution. So it will simply will not hold. So this is actually the Wronskian of u and v. So this also you can check whether it is an independent solution or not. So now we have got a condition that it will be an independent solution provided a must be non-zero. All right. Now we moreover phi and psi are chosen in such a way in such a way that we will write that equation. So, that is u into what was it, u into del psi by del x, what was it, u into del phi by del x, u into not del, d. So, u into d phi by dx plus v into d psi by dx must be equals to 0, and what was the second equation? Second equation is d phi by dx into du dx d psi by dx into dv dx equals to capital X. So, the phi and psi will be chosen in such a way such that this holds, and from there we have got this, right. So, now we can solve for phi and psi, and we know directly what will be the formula. So, we can write down the formula directly, and that will be given by phi is equals to, so d phi by dx equals to, that means from here we can write our phi x as a c1 plus integral, what was it, v into capital X. What is our v? V is sine of Ax. Now, here you have to be a little bit good with integrals, and then we have sec of Ax divided by what was it, u into we have u, let me see the formula. So, we have v into du dx, v into du dx, v into du dx, that means v is sine of Ax, okay, and du dx. So, du dx will be minus of a sine of Ax, okay, minus of u into dv dx. So, u is cos of Ax, and then dv dx is a cos of Ax, right. So, because we are doing dv dx, so a cos of Ax, d of x, this is slightly lengthy to calculate, nothing else. So, we will have sine of Ax, sec of Ax divided by, so this is u into v, u into capital X, no? So, no, this is cos, sorry, u is cos, my mistake. So, u is cos. So, this is cos of, now it will double, right. So, this is cos of Ax, so this is also cos, this is cos of Ax, and here I will take minus a out. So, I will have cos square x plus sine square x, d of x. Let us go to the next page, and this will become c1 minus 1 by a. I have cos of Ax and sec of Ax, d of x. So, cos and sec will be 1, and this will be simply dx. So, I will have c1 minus x by a. So, at least now I know my phi. Now, I will determine my psi. So, psi of x will be minus of integral, the formula says capital U, capital, just a minute, let us go back to the previous slide. So, this is phi. So, I think for phi it was for phi we will have sine itself, no? Right. So, this was already correct. So, we have to, so I am confusing. So, u is equals to, I have sine of Ax, cos of Ax, I am taking cos of Ax, and v is equals to, I am taking sine of Ax. Okay. So, according to the formula, this should be v, v of x. So, v is sine of Ax, right. So, this was already correct. So, this should be sine of Ax, and then this will be sine of Ax. Not much will change. So, we will end up getting tan here, which is still okay. So, this will be c1 minus, it's not changing much, I mean it's just sine of Ax divided by cos of Ax, nothing much is changing, yeah. So, d of x, so this is c1 minus 1 by a integral of tan of Ax. So, you have to know what is integral of tan x with tan of Ax. So, this will become c1 minus of 1 by a square log of cos of Ax, right. So, we know our phi. Psi can also be determined in the similar fashion. So, psi formula is, let me write again and I will put the value of u and v correctly. So, minus of u capital X d of x divided by v du dx minus u dv dx. Achha. So, let me just write very briefly what is my u, so that I do not make a mistake again, and v is sine of a x. Okay, so this is plus C2. So, we will have C2 minus u is cos of a x and capital X is sec of a x divided by v, that means sine of a x, and then du dx, that means minus of a sine of a x, and then this is minus of u, that means cos of a x, and then dv dx, that means a into cos of a x d of x. Okay. So, this will give C2 minus cos and sec, that will be 1, and from here we will get minus of a out. So, it will become 1 by a and we will have dx. If there are any sign error, that you can fix. So, if there is any mistakes with respect to signs, then you can fix. So, therefore, the complete primitive, the complete solution or primitive is given by y is equals to what was it, phi u plus psi v, right. So, phi writing from there C1 1 minus a square log of cos of ax into u was cos of ax, okay, and psi is C2 plus x by a into v is sine of ax. So, this is the required solution of your given ordinary differential equation, d square y by dx square plus a square y is equals to sec ax. So, when we proceed by method of variation of parameter, what we are basically doing, we are playing with the constants, so a and b from the complementary function. So, instead of taking a and b, you are taking just two functions phi and psi, and our ultimate goal is to determine that phi and psi. So, that phi and psi can be determined by solving that 2 by 2 system. And if you remember, you just have to remember this formula and the formula for u, and do not make an error like me. So, there you have to identify your u and v very clearly, and then you just substitute for u and v and then do the calculation, and yeah, then it is just an integration, simple integration for this type of integral, whatever you will end up here, and yeah, then you can substitute in your y is equals to phi u plus psi v. You already know your u and v, now you know your phi and psi, multiply them, and here your C1 and C2 will be arbitrary constants, are arbitrary constants, right. So, like that there will be many examples, but the working principle, the basic idea behind it is always same. So, I will write down one more example, and I will write down the major steps, and you can just verify whether you also end up getting the similar type of solution or not. So, this part we do not need. Let me write down another example. So, example 2, solve by the method of variation of parameter the equation d square y by dx square minus of y is equals to 2 by 1 plus e to the power x, right. So, from here your complementary function for the homogeneous equation will be y is equals to a e to the power x plus b e to the power minus of x. We can see it very clearly because it will be m square minus 1. So, m will be plus minus 1, and from here we will construct our solution, the complete solution, as phi e to the power x and psi e to the power minus of x. E to the power x and e to the power minus of x are independent functions. If we check their Jacobian, it will always come out to be non-zero, right. So, they are definitely independent functions, and we have this setting, and from there we can write our phi as, so this is my u, this is my v. So, phi formula is I think C1 plus integral of v x dx divided by v u dash minus u v dash, and psi formula is as usual C2 minus u capital X dx divided by v u dash minus u v dash. So, from here you just substitute your x, which is this thing, this is our x, right, and this is our v, and similarly this is our u. Then you substitute, you calculate these derivatives. Ultimately our phi, hopefully you will end up getting phi as C1 plus C1 plus e to the power C1 plus log of 1 plus e to the power x by e to the power x minus of e to the power minus of x, and psi will be C2 minus log of 1 plus e to the power x, and therefore our complete solution y will be phi u plus psi v, where phi is given by this, u is given by this, psi is given by this, and v is given by this, right. So, there will be many examples, but they will follow the similar working principle, right. So, we have covered the method of variation of parameter in this lecture, and this concludes our chapter, let us say 9, or then now in the next class I will start with series solution, right. So, basically if we have singularities and all those things, then how do we